I'm Dr. Ricoh, Technology Analyst covering 3D printing at IDTechEx, and I'm joined today by Mr. Dave Varty from Ricoh Europe. Mr. Varty.
Good morning.
Good morning. Could you tell me a little bit more about Ricoh's activities within 3D printing, but also more broadly, what you're up to?
Yeah, so Ricoh is best known as number one in document management and in the cut sheet markets for office digitization. From that, we've got a number of core skills that we've brought out, and additive manufacturing is one of those areas where we can implement those skills. So fundamentally, knowledge of toner allows us to manage powder, and those powder technologies allow us to use different applications within the additive manufacturing market. The first one of which is behind me, and this is laser sintering. So we're looking at industrial scale applications for particularly automotive, aerospace, but it has spin-offs into healthcare. And we're talking here about the ability to do functional prototyping, so not just a one-off, but also small, short runs of 10 up to maybe 100 devices. This SLS technology is fundamental to the systems that we sell, and these are large-scale systems and not desktop, so hence the reason we call it additive manufacturing and not 3D.
Absolutely. All right. And these are polyamides that you're using here?
We have polyamides, but we also have polypropylenes and PBT, which we're demonstrating here. So the powders where we can add value, glass bead technologies, really for more robustness, but also to be able to weld into existing extruded applications or injection molded applications.
Okay.
The spin-off from this is where we can combine other technologies, which is inkjet and additive manufacturing together.
Right, so this is a little bit of an example of where you're moving towards.
Yeah, so this case demonstrates the combination of our print head technology and also of the evolution and revolution of new materials that we are working on in Japan. One of which is this, which is a very tactile method of producing synthetic organs. Synthetic organs is not a morbid application, but it's used primarily for medical training, where real body parts are difficult to come by. We can simulate with a cyst, different colours. We can also put the internal workings of an organ together. And you see in the case here, we have another example of the kidney, we have a liver, we have a heart, and we also can create hollow structures with veins. And that's for medical training, so catheter training. For the livers, we can actually take the 3D CAD and make an MRI of a true patient's dimensions, and that allows the trainee surgeons to practice on something that is far less expensive than a real material, and of course it's in far better quantity and supply. This maps with printhead technology that already exists in the market, and if we use a different technology, we can then start to work on additive manufacturing, which is a binder process whereby we're encapsulating glass, ceramic, metal, PEEK, so heavy engineered or specialist engineering plastics, but we're not damaging the internal parts, so we're not sintering it as we produce it. We put an encapsulation around, going back to what I was saying about our competence in toner, which is an encapsulated pigment. In this case, it's an encapsulated metal, glass, ceramic, which we then react with an aqueous fluid to create the bond chemically rather than by using heat or laser.
And so the part that you would obtain after that, would that need to be sintered to debind it away from the aqueous binder, or could you use it as is?
It depends on what the base material is. With PEEK, the great thing about this is typically when you sinter PEEK, you have to dispose of all of the waste materials. What we do is take it out, shake it, and we can reuse all of the spare materials already. If it's metal parts, we don't sinter it as we produce it. We produce the part first, and then we effectively bake it rather than sinter it afterwards. So we're post-treating the finished product.
All right. And so my final question is, what do you think of the IDTechEx Show?
Well, this is our first time exhibiting at IDTechEx. I've been here for the last 3 years, and I think it's a great opportunity for us to bring some new applications from R&D to get people the experience of what the market's looking for, and to network with people who are potentially partners or even customers for these products. And we can feed that information directly back into our R&D department. So an example of a new product. This is the first time that this has been shown outside of Japan. And what we're looking at here is energy harvesting. So we're using a solar dye cell, which is the red part, although we can make different colours, yellows and blues. And we're capturing it either on a solid sheet, such as this, and this is what's powering the turntable, just from the ambient light, indoor light. Or we have a flexible application here, which could be applied to wearable technologies and more robust applications. And that again is powering the LED. So everything that you see twinkling here is being powered by the operation in the cell. And you have it for sensors, either gas sensors, CO2 sensors, temperature sensors, but also one of the key areas for this is IoT applications where you want to place a sensor but you're never going to change the battery.
Yes.
So you need to be capturing energy all of the time. And with our semiconductor business, we also have low-level energy management for automotive, for things like key fobs and infotainment. So we have energy harvesting. We also have low-level energy management within our cell. And this really is a showcase for this product and to enable us to really gather some market feedback as to where we take it.
Great. Okay. Well, thank you very much for this very
Pleasure.
informative interview. Thank you.